introduction to tomorrow's lesson, and that's just some basic stream systems vocabulary. And some of you guys have probably noticed you have this thing called a watershed. What does that mean? I'll give you a hint. It's not a shed in the backyard full of water.
Is it like a spot?
Yeah, what do you mean a creek type thing? Okay.
Don't worry, once you say it.
It's somewhat related. Okay.
Is it kind of like a river without water?
Well, yeah. Because what is a watershed? It's basically, when we think about a watershed, it is the area that drains to a specific body of water.
Basically just holds it.
No?
I know what it holds on it.
Well, you know, we have a lot of different watersheds in our area, and basically this map that you see here, this is the St. Joe River. And what you're looking at is the St. Joe River watershed. Notice that includes us, Auburn, Butler, Fort Wayne. And now, here's something that's really important. This map shows you the land that anywhere inside here, no matter where you're at, that water eventually will drain into the St. Joe River. Now, why is that important? Why would this be an issue to be concerned about what our watershed is and where our water goes?
Just in case the water overflows?
Kind of. It would kind of definitely affect us in terms of flooding. What are some other things that would be worthwhile to know what our watershed is? Okay, let's put it this way. Let's suppose that there's a factory located in southern Michigan, and they start putting a bunch of bad stuff out in their backyard. That's what a lot of factories do. They dispose of their extra stuff. Yes?
So certain companies that have waste products or whatever can't be in that area.
They are allowed to be in the area, but what
they
they're not.
Dispose of it properly.
There we go. They can't just dump chemicals because that one spot here in Michigan affects the entire watershed. So what it seems like, you know, something that might be 100 miles away, we're like, we're not really too worried about it. It's 100 miles away, but it does affect us. It affects our entire watershed. Especially if you're in Fort Wayne, who's downriver, all that drain is going to come into Fort Wayne, and if Fort Wayne's using that water to give to their citizens, that's a big issue. Okay, so that's our watershed. This line right here is called a divide. And think of it like a continental divide, guys. What is the continental divide? Have you guys heard of that before?
Yeah.
Have you taken geography before?
Unfortunately.
What is, Gabby, the continental divide? Yeah, I'll give you a hint. The continental divide runs right down the backbone of the Rockies.
That's continents.
That's what I was going to say.
Okay. One person from each table. You have 2 minutes to find a good definition of continental divide. You can put it in their own words. What is the continental divide? Perry.
A series of ridges in the Rocky Mountains in North America.
Your own words.
Okay, own words, Perry. What does that mean?
A series of ridges
That do what?
form a watershed to separate rivers flowing east from those flowing.
Yes, what does that mean? Think about it, guys. What is the continental divide really doing?
Separating the water
And how's it separating the water?
by rivers dispersing everywhere.
Okay. Well, if I'm on one side of the continental divide, here it is. If I'm precipitating on this side, that means all the water is going to drain in that direction. If I'm over here, then all the water drains in that direction. Okay, which basically means this is a ridge. So what these are, this line is actually the highest point or locations. Gentlemen, I'm a little irritated. So this black line that we see here is basically the highest points, the ridges. And anything that inside here is all going to drain down toward the St. Joe River. So that's why we call it a divide. Now, some other terminology that's worth noting is this concept of stream load and carrying capacity. And what I want you guys to know out of this is just really basic stuff. And stream load is basically all material that a stream carries. And there's basically two types of load. You have suspension, so all these little specks in the river floating, that's being held in suspension. And then you have the stuff on the bottom of the river, and that's called bed load. Write that down. So in suspension, again, that's all the stuff being carried by the river. Bed load is the stuff on the bottom of the river, thus the river bed. Now here's what's interesting. Look at how they flow.
So suspension flows faster than bed load.
Okay, yes, suspended materials flow faster than bed load. What can you tell me about their sizes?
They're bigger, they feel heavier
Alright, so they're bigger. Where are they bigger at?
on the bottom.
On the bottom, okay, so they're more dense on the bottom, the less dense are in the water column. Okay, how are the ones on the bottom moving?
They're getting a little less.
So, okay, the small stuff is floating. Well, how's the other stuff on the bottom moving?
Rolling.
They're rolling. So what shape are river rocks?
Circle.
They're circles.
But
Okay.
that,
So typically when we find rocks in moving water, they're typically rounded over. Okay? So these are basically river rocks. These are rocks that came out of the river, and they're well rounded. Just like we expect you guys to be when you leave high school. Keyword there is expect. Okay? So, all right, now, here's the whole thing though. The stream load is directly connected to this thing that we call carrying capacity. And in the carrying capacity, what that means is it's the amount of material that the stream can carry. It's the maximum amount of material the stream can carry. I'd write that down. And that carrying capacity is completely related to the velocity of the water. The faster the water is moving, the more it can carry. Pretty simple. It's directly proportional. So the faster I'm moving, the more I can carry, the more sediments I can carry. Therefore, if my velocity slows down, what happens to that material? Can it be carried any longer? So what does it do? So if it stops being carried, what does it do? It drops to the bed. Okay? And so what will happen is this stuff that's held in suspension, if this river slows down, all these suspended materials will fall out of suspension and start being deposited onto the stream bed. All right, and that pretty much sums up our lesson for today.